the computational scheme of regular falsi method. How to use that method to get the root of a transcendental equation. So the example is, compute the root of the equation. Compute the root of the equation 2x minus log x minus 7 equals 0 by regular falsi method. By regular falsi method, which lies between 3 and 4, which lies between 3 and 4. Correct to 3 decimal places. Correct to 3 decimal places. Okay, so start it. Fx is this 2x minus log x minus 7. Now check about f3. What's the value of f3? 2 into 3 minus log 2 minus 7 minus 1.48, and f of 4 equals 0.40. This is less than 0, this is greater than 0. That means one root lies between f3 lies between 3 and 4. So we can use the procedure of regular falsi method. So making the table, first is n, then an. Now initially for n equal to 0, we will take the value a0, which is this 3, a0, b0, 3, 4, and which is negative, so put the negative sign here, and then bn, which is positive, so put the positive sign here. Then f of an, f of bn, then the value of hn. Next is xn plus 1, which is equals xn plus hn, an plus hn. I'm writing the value here, an plus hn, and then f of xn plus 1. Okay, so starting the computation, n equals 0, then the initial value a0 is 3 and b0 is 4, then f of 3, which is minus 1.48, f of 4, which is equal 0.40, then compute hn. The rule for hn is hn equals modulus of f of an into bn minus an by mod f of an plus mod f of bn. Putting the value one by one. We have already calculated f of an and f of bn. Just put the values and you will get the result for hn. The value is 0.79. Then xn plus 1, which is equals to an plus hn. That means this one plus this one. So this will be 3.79. Then f of xn plus 1. Put that value over the function, which gives the value 0.0014, which is greater than 0. Okay, that means this part will replace the positive part in the next iteration. That means this 3.79 will go to this positive part. This bn part is positive here, so the new bn will be 3.79 and the old an will be the same. Step number 1, find the same thing. Then f of 3 will be minus 1.48. Compute f of 3.79. it is 0.0014. Then compute Hn. If modulus of f of n into bn minus n whole divided by mod fn plus mod fbn. Put the values. Then we will get the value of Hn as 0.789. Then this plus this is our xn plus 1, that is 3.789. Okay. Now f of xn plus 1, it gives the value minus 0.00052, which is negative. That means this xn plus 1 will replace the new negative term, that is an. So our new an will be 3.789. So 3.789. bn will be same. Step number 2, find out the value. It will give minus 0.00052, and this value will be same, 0.0014. Compute Hn just by similar manner. It gives the value 0.000271, and then xn plus 1, so it will become this plus this, so 3.789271. Then put it values over the function f, and you will get f xn plus 1. It will give the value minus 0.000014, which is negative. Now check which is the terminating step or not. This is the terminating step or not. We need correct to 3 decimal places. Here it is already same for this and this up to 3 decimal places. We can do one more step just to verify that this is continue up to 4 decimal places or not. You can do one more step. So we are doing one more step here. So we have to put this one for the negative part, that is 3.789271, 3.79. You can stop at that step also, because we already get 3 decimal places same for 2 simultaneous steps. I am doing it just to check for the next step. You can stop it here also. Now get the value. This will be 0.0000014, and the next one is the same thing, 0.0014, and this value Hn is 0.0000007, and this one is 3.789217. Yes, this is also correct. That means this is our required result. This is our xn plus 1. So the approximate value, the root is 3.789, and we have to make it correct for 3 decimal places. We have done this. No, actually according to the question we have to make it 3 decimal places. That is this one. Correct up to 3 decimal places. Okay, this is how we apply regular falsi method to get the root of a transcendental equation.